Hello, guys. Welcome to Beyond the Bites. Today, we are going to be going over selection sort. Now, it's still recruiting season, which is a time where people go crazy looking for jobs, doing interviews, interview prep, and all things stressful. Okay, because I don't find any of this not stressful. Whatever the opposite of stressful is. Anyways, so today we're going to be taking a look at selection sort. Last time we took a look at bubble sort. So if you haven't already taken a look at it, then please do. As usual, I'm not going to be coding because there are a whole lot of coding videos on YouTube. Not to say that there are not these type of videos on YouTube. There are a lot of these as well, but I just feel like there are a lot more coding videos than there are these types, like the whiteboard or blackboard type. But anyways, if you're very interested in looking at the code in depth, then I have a very well explained code on Medium. The link will be in the description. It is long, okay, because I take my time to explain every single step there is in solving a problem, sorting a piece of, code, sorting an array using selection sort. So if you're interested, do check in my description to find a link to the Medium article that I wrote. But another thing is that I do have a podcast that is all about, things that are really beyond the bite. Like we're looking at coding assessments and how to prepare for them, technical interviews, behavioral interviews, and, like even depression and all kinds of stuff. So if you're interested in that type of stuff, do check it out. Each episode is about like 20-25 minutes. So it's not too long, but yeah, it's very informative. And I do my best to give as much information as I can to help you from my own experience. And I'm not an expert. But, anyways, I'm blabbering way too much. Let's just get into this tutorial. So, today, like I said, we're going to be going over selection sort. And selection sort is an in place algorithm, just like bubble sort. And what happens when you're doing selection sort? So, we're going to say, by the way, the green, this is the sorted version of this. But anyway, so we're going to take two and we're going to pretend, and I'm going to explain all of this. I just want to give like an overview of selection sort. So we set a minimum index and we go through it. If we find something less than the element at the minimum index, we say that this new place where the smallest element now sits is well, it houses that's where the minimum index is, and that index houses the smallest element in the array. And at the end, we swap this with the place where we started. And this is all going to make sense. What I just said probably doesn't make sense, but we're going to go through it with this and changing things up here so that you can better understand. I'm going to try my best not to write a lot. I know I said whiteboard, and so that goes with writing, but I'm not very comfortable with this graphics tablet. So I'm going to try not to write because it's going to look messy and I don't want you to lose interest. But anyway, so we start right here. We start with a for loop, just a basic for loop. And int array is this, by the way, it's just an array of integers. So we start and we have a variable called min index. And as you can see here, min index is set to I, right? So I is equal to 0. When we start, I is equal to 0 and j is equal to I plus 1. The reason why I don't do j is equal to 1, which it looks like j is equal to 1 and j is equal to 1, but I don't do 1 because, well, what if I wasn't 0? We always want j to be the next element after I. Starting, at least at the starting place, it should be the next element after I. But if j is equal to 1, and you'll be incrementing, so it will just work. But what if suddenly you just end up changing I, which would never happen, but I just like to just prevent it. So I just like to use I plus 1. But that's just that. Anyways, so and we say, why do we say minimum index is I? Now look at something. Let's say that there was a curtain right here and we couldn't see any of these. Just pretend, go along with me. we couldn't see any of these elements, right? And 2 was the only number that we could see. Well, in that case, we can't say that the minimum element in this whole thing is at 2, because 2 is the only element that we can see. Right now, the minimum element would change as we go along and we look at other numbers. In this case, 2 will become the minimum element in this whole, array. But if 2 is the only one that we can see so far, then 2 is the smallest, right? And well, minimum index will change as we go on. We say that the smallest element is sitting at index 0. The smallest index right now is 0, because that's where the minimum element is sitting, right? So minimum index is not the smallest index. We're not talking about indices. We're talking about the place where the smallest elements sit, right? Not the index. Because, well, in that case, the smallest index will always be 0, right? And so what would be the purpose of this? Minimum index just refers to the index at where the smallest element sits, right? And right here, we're grabbing the elements. These are grabbing the indices of the elements, and these are actually grabbing the elements themselves, right? So array I is starting at 0. I'm starting at 0 as well. So array I is actually equal to 2, and array j, which is I plus 1, which is 1, because 0 plus 1 is 1, is 0, right? That element is 0. And the array at the minimum index, which when we start is also I, minimum index is I. The element at I, or the element at minimum index, is 2, right? And 2 is the smallest so far. Imagine, again, we have the curtain and we can't see any of these. But moving along, we are going to say, we're going to loop through, right? This second for loop right here. And let me try, I'm going to try to limit. We're right here. Can't see that, can you? Let's see. Better. We're right here, right? J plus 1. So we start off and we say, well, oh, geez. So when we start off, we say that, well, if the element at j, so if array j, which is 0, right? So if the element at j, at the index j, is less than the element at the minimum index, right? If this is the case, then we want to swap. Let me just put this in plain English, right? So we want to say, well, what is the element at j? The element at j is 0, and the element at the minimum index is 2. We want to say if 0 is less than 2, then we want to set the minimum index to j. What this is saying, if 0 is less than 2, and mind you, minimum index is currently here. We're saying that the minimum index is sitting at, the minimum element is sitting at index 0, right? Right now, we're saying minimum index is sitting at index 0. If 0 is less than 2, which it is, then the minimum element is not sitting at index 0. It's actually sitting at whatever index 0 is. And 0 is sitting at index 1. So we say that, well, index 1 houses the smallest element so far, at least until we go through everything else and find a new small element if there is, right? So right now, we're going to say that the minimum index is actually sitting at j. The reason why we put j is because j is the element where we are, right? J is actually I plus 1, so j is right here. Let me pick up my handy dandy. J, when we start, is right here, right? Oh, that was bad. All right, so j is actually right here, right? Because I plus 1, I is right here, and I plus 1 is right here. So j is right here, right? So we say saying j would just grab the index of 0 instead of putting the element itself, right? So we say that the minimum index is actually here, right? And not here, because this number is small. The element here is smaller than this, so the minimum element is sitting at index j, whatever index j is, right? We are going to keep going through. Now we're going to say, so now So now we need to update some stuff. J is actually, so J. So we did some updates, right? So right now, J is at index 2. So J, we're going to start right here. Since we've already got this figured out, we're going to continue the comparison starting at 5. And so the minimum index right now is actually not this. The minimum index is going to be J, but before then it was 1, right? 0 sitting at 1. So the minimum index right now is 1. And the array of index of the minimum index, which this is grabbing the element at the minimum index. The element at the minimum index is 0, right? The element at index 1 is 0. And J, we're going to start right here. I is going to stay at the same place. So I is still, array of I is still 2, and I is still standing at index 0. So now we take a look at 5 and we say, well, is 5 less than the the minimum element, or the element at the minimum index? And it's not. 5 is not less than 0, so we go on to the next one. So now J is equal to 3. We look at 3, and well, that is going to be 8. And we compare, well, is this new element, 8, is it less than 0? And it's not. So we move on to the next one, and then now we're going to check it with 4, and J is going to move to 4. Coincidence, but it's 4 less than 0, and it's not, right? So we're at the end. Now we get out of this loop. We get out of this. Let me grab this really quickly. We get out of this loop, and we're here. We're right here, and this is critical. Now, not too critical, don't worry. I just said that to scare you. I hope you didn't get scared. Anywho, so what we're saying right here, this is simple. This is just a swap method, right? So don't get scared. It's okay. All we're doing is we're swapping two elements, nothing serious, right? But I just feel like this is important to remember, because why are we doing this? Now, if the least element, the smallest element in this whole array was sitting right here, let's just pretend like 0 wasn't in this mix and this number was like 6 or something, right? And 2 is the smallest. We're going to loop through and we're not going to find anything less than 2. So indeed, the minimum element will be sitting at I, right? So we say, and in that case, min index will be I and it will never change. Min index will be 2 and I will also be 2, right? So we say, no, I mean, min index will be, the array of min index will be 2 and the array of I will be 2, but min index will be 0 and I will also be 0, right? Or I will be 0 and min index will also be 0, since I comes before min index. But if we don't find anything less, then we don't have to swap anything, right? Because 2 is the least element. And all that we're doing is we're trying to push all the small numbers to the front. If we find something that's smaller than the index which we are at I, then we're going to swap I with that small element, right? We're trying to push the small numbers to the front. And if we don't find any small number, which means I is housing the smallest element there is in the whole array, then we don't need to swap, because the whole point is to get the smallest element to the front. But if the front is housing the smallest element, then it's good. We don't need to swap anything, right? So to avoid doing unnecessary work, we need to check if the minimum index is equal to I. If it's not equal to I, which means that the minimum index is not 0, it's another index in this array. In this case, it's 1, right? The index for 0 is 1. So in this case, we need to swap I, and we need to swap the element at I and the element at the minimum index, right? And that is all that we're doing here. We have a temporary variable that is going to hold on to 2 for now. And then we're going to give 0 to this. We're going to put 0 right here. And then we're going to put 2 right here, right? Remember, temporary temp variable, the variable temp is holding on to 0. No, I'm sorry, it's holding on to 2. Oh my God, it's holding on to 2. I was talking about the index, but no. It's holding on to 2. That's the value. The index is 0 though, but it's holding on to 2. And so we're going to give 2 right here, which is the position where the minimum index was. That's all that we're doing. And as you can see, whenever we're done with the first iteration and we're done with all of this, well, we'll have 0 and 2, just like we have right here, like right here. Okay. And then we're going to take care of all of these, and we're going to take care of all of these, and then things are going to be perfect. Okay, so after the first iteration, this is what we have, right? And so we're going to move on. Now you can see we've incremented I. I is now equal to 1. So we're going to be starting right here because we've already got the smallest element in the rightful place, or the right place. And J is naturally going to be the next element after I. And the minimum index is again going to be at 7. We're going to say the minimum index that we know of is sitting at the place with the minimum element. The minimum element right now is right here, at least after this one. We know that the minimum element is right here. Well, we don't know, but we're saying that it is because let's just pretend again like there's a curtain, and 0 and 2 is the only number that we can see that is housing the smallest element. Forget about this because this 0 is sorted. It's at a good place, so we don't worry about it. We have to worry about everyone else that's not sorted. And 2 is the smallest out of everybody that's not sorted. At least that's what we're saying, until we find something that's smaller than 2. And so, well, the element at I, which is 1, is 2. The element at J, which is 2, because 1 plus 1, so J is equal to 2. The element at index 2 is 5. And the element at the minimum index, well, is 2, because we said 2 was the smallest that we could see among the unsorted bunch. So we're going to do the same thing again. We are going to check if the element at J, which is currently 5, if 5 is less than 2, then we will say that J is holding the smallest element in our array. But 5 is not less than 2. So we move on. We increment J to 3. We increment J to 3, and all of these are going to change. J is now going to be equal to 8. I don't want to update it because we just will waste a lot of time, but I hope that you can follow. J will now be equal to 8. Actually, I'm going to change it. J will now be equal to 8. And we are going to say, well, is 8 less than 2? And it's not. So we are going to, again, increment J. And J, the element at J will be 4. J will actually be incremented to 4. Is 4 less than 2? And it's not, so we're done. Now, this is what I was talking about last time. We don't need to do this step because the minimum element, the minimum index is I, right? And I is equal to 1. The element at the minimum index is 2, right? The minimum index is index 1. The element at index 1 is 2. And well, I is equal to 1. Array of I, the element at I is also 1. It's also 2. I'm sorry. So we don't need to swap since minimum index and I are the same thing, right? The minimum index is sitting at 1 and I is also sitting at 1. So we don't need to swap anything. So we're simply going to move on and do some more, sorting. All right, so I updated some stuff after the second iteration. This is the array that we're going to have. And now I is equal to 2. So the element at 2, or index 2, is 5, right? And that's what we have right here. The element at J, which is I plus 1, J is I plus 1. The element at J is 8, right? And well, the minimum index is, of course, as we always say, is sitting at 5. These are the sorted bunch, and these are not sorted, right? They have not seen the light. We're trying to get them into the light. And so we are going to say that the smallest element in this unsorted bunch is 5, right? Because that's what we can see until we go through and find another small element. And then we're going to say, well, the minimum index is actually not right here. It's at wherever the smallest element is. So let's just get going. Anyway, so we're going to say is array of J is the element at J, which is 8, is 8 less than 5. And 8 is not less than 5, right? So we're just going to increment J to, well, 4, right? We're going to increment J to 4. And well, the element at 4 is actually at index 4 is actually 4. I don't want to take time off to, do some more stuff, cleaning up and stuff. This is okay for now. And we say, well, is 4 less than 5? And 4 is less than 5. So we say, oh, well, the minimum element is actually not at 2, is actually at index 4, right? So we're going to have to now check, is the minimum element, I mean, is the minimum index, which is 2, is it equal to, I mean, no, my bad. It's the minimum index, which is 4, right? The minimum index right now, the array of minimum index changed to j, which was 4. And so the array at the minimum index is 4, right? Because 4 is at index 4. That's very tricky. I shouldn't have used that number. Should have used a different number, but I hope it makes sense. Well, is 2 equal to 4? And it's not, right? So 4 does not equal 2. So we can go ahead and swap. So we're going to go ahead and swap 4 and 5. So we're back again, and we are saying now that, well, we increment I. So we're saying that the minimum index is sitting at right here, which houses 8, right? So, well, the smallest element is 8, and the smallest index is I, which is 3, right? Which is the place where 8 is. Now we're gonna do what we've been doing. Oh my goodness! And so we're going to say, well, is J, which is 5, is 5 less than the element at the smallest index? And 5 is less than 8. So we're going to go ahead and swap these two. And thank goodness that's the last one, because this video is very long. And this is the end of this the sorting. And as you can see, well, the fourth time that we loop, we are going to get this perfectly sorted array, which looks like what we wanted, the picture that we're looking at to create. And so this is the end of the video. Thank you so much for watching. If I didn't help you, then I'm sorry. If I did, please give me a thumbs up, subscribe, check out my podcast, and also take a look at the code that I said was well explained on my Medium. Thank you so much.
It's Emerald P on the beat.